All right, so 7.5 part 1 is on what we call Sum Difference Identities. We might end up finishing all of 7.5 today because I really want to spend more time on 7.6. And I'm going to cut some material out of 7.5, so if you did look at like a lesson from last year, it's not going to match up exactly with this year. All right, so first of all, let's just look at that. Sine of x plus 3 versus sine of x plus sine of 3. I want to just think about what's on the left and what's on the right in terms of like a transformation. When you add or subtract a number inside parentheses, which way does that move the graph?
Horizontal.
Right. This plus 3 is going to move it left or right. Specifically, plus is going to move it to the left. So that's a horizontal shift of 3 units. How about when you add something on the end? Which way does that shift at?
Vertically.
Vertically. So is a horizontal shift and a vertical shift the same thing? Not usually. I mean, you might be able to find like a special case where it is, but in general, they're not the same thing. So the point is you can't take sine and like just distribute it. That distributive property doesn't work with functions. It works with numbers. Okay, if you've got a number in front, you can distribute it, but not a function. So then the question we're going to look at is, well, what can you do with this? When we're dealing with any trig function, we don't want to have plus a number inside parentheses. We don't want to have plus a number. We don't want to have minus a number. We don't want anything inside. So what we're looking for is a way to get rid of this plus 3. And that's what I'm going to show you. Okay, we're going to look at 4 formulas. You can have a plus and have a sign on the outside. You can have a minus here and have a sign on the outside. Those are 2. You can have a plus on the inside with a cosine, or you can have a minus on the inside with a cosine. So depending if it's a plus or a minus, and a sine or a cosine, there's a formula to get rid of the plus or the minus. Okay. So the first one we're going to look at is the formula for cosine, and it's when you have subtraction inside. Okay, and I'm going to call this the cosine difference formula. So we're going to learn cosine difference, cosine, bless you, sine difference, sine sine. Those are the 4. There are ones for tangent, but we're going to, that's one of the things I'm going to cut out. So we're not going to look at the tangent ones. So that's the formula for cosine of a difference. The alpha and the beta would be 2 numbers. Okay? There'll be 2 numbers there. So the pattern is, I call this one the first angle, and I call this one the second angle. So it's cosine first, cosine second, plus sine first, sine second. That's the formula. And as far as why that's the formula, well, the proof is, it's in our book. It's a little complicated to go through. So we're not going to prove this one. We'll prove one of the other ones that's easier. Okay, but this one's a little hard to prove. Well, I should say it's more time consuming. And I really don't want to spend like 15 minutes just proving that. Okay, let's see. Well, the other thing to notice is look at the symbol you have here and look at the one you have here. It's the opposite. So whenever you're dealing with a cosine problem, if you have a minus here, you put a plus here. What if there was a plus here? What do you think would be over here? A minus, and that's exactly what the next formula is. That's the only thing that changes. So, well, let's try this one first. That's it. All right. I want to find, I'm going to use that formula somehow to find the exact answer of the cosine of 15 degrees. Now, before we get into that, I want to go back and just kind of review something we've done before. Bless you. Okay, when we did the unit circle, we found sines, cosines, and tangents of certain angles. 15 was not one we ever did. Does anybody remember what the angles that we did? They were all multiples of two different numbers. Yeah? 45s and multiples of 30s. Yeah. So we did all the 30s and 45s. If you draw them out, there's your 45, there's your 30, there's your 60. And we did those three in every quadrant. So we did the 45, the 30, and the 60, 45, 30, and 60, 45, 30, and 60. So we did angles like 135, 150, 225, 315. Okay, we did all those angles. But if you look at them, they're not all equally spaced. You're missing this one and that one in quadrant 1. In quadrant 2, you're missing those. Quadrant 3, quadrant 4, and so on. Okay, so the green ones are the ones that we're going to add in. And we're going to use the formula I just showed you. This is 15 degrees. Okay, what do you think that one is up there? That's the 75. Yep. So now we're going to be able to do the 15 and the 75 in every quadrant. Okay. This one would be 15 past 90, so that's 105. That one's 15 before 180. So what do you think that one is? 165. Yep, 165. I mean, we don't have to label them all, but you get the idea. Now, the two that are going to be important to figure out 15 are the 30 and the 45. Okay, we need to just kind of write down what we already know about those. So for the 30, okay, the 30 had an x and a y value with it. Here's your 30. So it had a long side and it had a short side. Does anybody remember what either one of those sides were? The short side or the long side? Yep. Square root of 3 and 2. Square root of 3 over 2 is the long side, which in this case is the x. Yep. And how about the short side? The side doesn't have a square root. Anybody remember short side? Yep. Half. Yep. It was a half. Okay. We're going to need that coordinate to figure out 15. The other coordinate we're going to need is 45. 45, 45, 90. That's that triangle. Each side is the same here. The x and the y. It's isosceles. Does anyone remember what each side was? Yeah? No. Yeah?
Was it square root 2 over 2?
Yeah, both sides are square root 2 over 2. Did you have another
I have a
question?
separate question.
Yeah.
So why couldn't we just do cosine 45 minus cosine 30 to get cosine 15?
That's exactly what we're going to do.
Oh, okay.
Yep, that's exactly how we're going to figure it out. So the way you figure out the 15s is you have to use the ones you already know. The only ones that you know already are the red dots. All the 30s and 45s. So let's take cosine 15. And we're going to rewrite that in a way that uses a minus. Okay? And then we'll have a formula we can figure it out with. All right. So let's rewrite it. And it was already suggested how we rewrite it. How can you rewrite 15? Using 30s and 45s somehow.
45 minus 30.
Right, 45 minus 30. Okay. So now, let's put the other page up. Let's look at what the formula is, and we'll look at our two angles. So in our case, alpha my first angle, that's going to be 45. So everywhere I have an alpha, I'm going to fill in a 45. And everywhere I have a beta, I need to fill in 30. And we have to fill them into this formula right there. That's how you have to do it. Yep.
Does it matter what order you put them in?
Well, you mean when you subtract them?
Yeah.
Yeah, because if you do 30 minus 45, that'd be negative 15.
All right.
If we were doing negative 15, you could do it that way. But we're not. So. Okay, so now let's fill it all in. So what I usually do first is just write it down like this. Cosine, cosine, sine, sine. And now fill in everything. So alpha, beta, beta. Okay, so alpha, beta, and then alpha and beta. Alpha and beta. All right, now we just have to figure out what those come out to. Okay, when we did unit circle, cosine is a certain letter in the coordinate. Does anyone remember what letter the cosine is? Yeah?
X.
Yes, it's the x. And how about the sine? We're going to need that one in a little bit. Sine is always the. Yep, sine is the y. Okay, so let's figure it out. Cosine of 45 degrees. What's the x value in the coordinate for 45 degrees?
Root 2 over 2.
Yes, root 2 over 2. Times. Now 30 degrees. What's the x value in the coordinate for 30 degrees?
3 over 2.
Root 3 over 2. Yep. Plus, now I need the sine of 45. That's the y value in the 45 degree coordinate. Okay, what's my y value in the 45 degree coordinate? What is it? Yep, square root 2 over 2. Times, and now I need the y value in the 30 degree coordinate. 1/2. Yep. Now we just multiply and add that up, and that's our answer. We're going to multiply these two first, and those two second. Okay. Remember, when you multiply, you just go straight across. Square root of 2 times the square root of 3, we can put that together as the square root of just one number.
6.
Square root of 6. And then do the bottom. 2 times 2, 4. And now here, what's the square root of 2 times 1?
Square root of 2.
So we get square root of 2. And then 2 times 2, 4. And now I just want to add these together. But what do you need to make sure you have when you want to add fractions? Yeah, well, we already do. So the common denominator is a 4. And all you can really do is that. That's the final answer. Okay. So let's check it and see if it works. So I'm going to type in the original problem. I'm going to type in the answer we got, and then see what we get. Okay, so the original problem was cosine 15. Let me just check the other. All right. When it gave us the original problem, was it cosine of 15 degrees or 15 radians? Degrees, yeah. So we're going to put it in degrees. Cosine of 15 gives me about 0.9659. Now let's type in our answer and see what we get. Let's do, oops. I want to leave that up there so we can see it. Let's do square root of 6. Oops. Square root's not working. Square root of 6 plus square root of 2 divided by 4. How does our answer compare to the cosine of 15? Same thing. Yep. So that's how you do the cosine of 15 and get an exact answer. Okay, so for this week's test, we're not going to be doing anything that's going to require like y equals and then pressing graph. So for this week's test, we're just going to be using a scientific calculator. We won't be using the regular graphing ones. I have some. They work exactly the same as those. The only difference is they don't have a screen to graph. Okay. Any question on that? You can bring your own. If you have your own scientific calculator, that's okay too. But I have like 20 or 30 of them. All right, let's try them. So this one says verify. They're asking you to show that this is the same as that. So what you have on the left is a cosine difference. So we're just going to take what's on the left, and we're going to fill it into the formula I just showed you. Can somebody remind me, what's the formula? You don't have to say the alpha and the beta. Just tell me, like, is it cosine and then cosine or sine and sine? What's the formula for the cosine of difference?
Cosine times cosine.
Cosine times cosine. Yep.
Sine times sine.
Plus sine times sine. Okay, and now you fill in your angles. 1, 2, 1, 2. Okay, what's gonna be my first angle that I fill in right here?
Pi over 2.
And what is alpha in this case?
Pi over 2.
Pi over 2. Yep. So pi over 2 is the first angle. And what's the second angle that's going to go right there? Theta. Yep. And then the first angle again. 2. And the second angle? Theta. Now, you can't do anything with theta because it's a variable. You don't know what it is. But pi over 2, we know what that is. What's pi over 2 in degrees?
90.
That's 90. What is the coordinate for 90 degrees?
0, 1.
Yep. That's all we need to do this problem. Okay, we need the coordinate for pi over 2, which is 90 degrees. Okay. So let's start with the cosine of this coordinate. Cosine is which letter? X. And what's the x in that coordinate? 0. So we get 0 times, well, cosine theta, we'll just leave it. Okay, I know something's going to happen. We'll talk about that in a second. Right, and now the sine of pi over 2. What's the sine using that coordinate? 1. Yep. Now what happens there?
The cosine and 0 cancel out.
Yeah, 0 times anything, that whole part is just gone.
And then the 1 in the sine just becomes sine.
Right, and 1 times sine becomes just sine, and that's exactly what they wanted you to show. So there are trig identities in this section, but that's as long as the proof gets. It's really like 2 steps. Okay, so any question how we showed that is the same as that. Yeah, we'll try one more like that, and then I'm going to do the cosine sum identity. Let's try this one. All right, so again, we have another cosine difference. So first thing we'll do is just write down the formula that we're going to fill into. All right. So can someone remind me again, what's the formula for cosine of a difference? Yep, just kind of the outline of it. Yep.
Cosine times cosine plus sine times sine.
Cosine times cosine. Sine times sine. Yep. And what's going to be the first thing I fill in right there? Yep.
Alpha, or in this case it would be pi.
Yep. So alpha just kind of stands for whatever the first angle is. This time it's pi. And my second angle is going to be theta. Okay, first angle, second angle. First angle again, pi. And second angle, theta. Now the one that's theta, you can't really do anything with it. But the pi, you can. What's pi in degrees? 180. So now, what is the coordinate for 180? Yep, negative 1, 0. So that's the coordinate you need to do everything. Okay, cosine is the x value. What's the x value of that coordinate? Negative 1 times cosine. Okay, plus, now I need the sine of 180. That's the y value for the coordinate. 0. Okay, and what's going to happen there? 0 times sine is 0. Yes, that's gone. Right. Cosine theta times negative 1 is negative cosine theta. So the formula worked exactly the way it should. Okay, so you'll have a couple on the test just like that. What I'll probably do is I'll give you something like what's on the left, and I'll say, write out the first step, like if you were going to prove it. So you'd have to write out maybe something like this. Any question on that? Okay, so that's the difference. Let's look at the sum formula. You know what? Let's just... I'm just going to show you what it is. So I'm not going to go through the derivation of it. I just want to kind of think about what it would be based on the formula we just did. So here's your cosine difference. There's only one thing that's going to change on the right side to make it a sum. Anybody have a guess what's going to change on the right side? Yeah, this changes from a plus to a minus. That's the only thing that changes. And that's going to be the cosine sum formula. So let's write that down. So cosine, cosine, sine, sine, and so let's pick, I got to pick two angles. Normally they're going to give you some numbers to work with. Let's just call them alpha and beta for now. So cosine alpha plus beta. Put your first angle there. Second angle there. It's just like the first formula. First, second. Except what did I say goes between them? What is it?
Is it minus?
A minus, yeah. So if you are going to make a reference sheet like we normally do, these are two formulas I would definitely put on your reference sheet. Okay. So that's called the cosine sum formula. So we did the 15. We just go back to the picture. Okay. We did this dot. Now we're going to do the one up here, 75. And maybe we'll try one of those other ones. Maybe we'll try like 105 or 165. See if we can figure one of those out. So how can you break up the number 75 as a sum, but it has to be two numbers that are multiples of 30 and 45. You can't do like 65 plus 10. That doesn't help. It's got to be 30s and 45s. Yeah?
30 plus 45.
Yeah, this one's is pretty much as basic as we can get. 30, 45. All right, so now fill in your numbers, and then figure out the coordinate that you need. All right, so we start with cosine, sine, sine. Okay, when we write it like that, I call this grouped. Okay? The cosines are grouped together on the left, and the sines are grouped together on the right. The next formula we're going to look at, the sine sum and difference formulas, the trig functions are mixed, meaning you have a cosine and a sine together on one side, and a sine and a cosine together on the other side. So they're mixed rather than grouped. Okay, but for now they're still grouped. And what goes in the middle for the sum identity? Minus. Okay. What's the first angle that we fill in?
30.
Yep, 30. Second angle? 45. First angle again? And second angle? 45. This time, just to kind of touch on a question that was just asked before, if you switch the order here, it's okay. Because 30 plus 45 is the same as 45 plus 30. You get the same answer. All right. Now we just need to go through. And again, if you don't remember the coordinates for 30s and 45s, I would put that on the reference sheet as well. Okay. So cosine of 30, you can flip back if you need to. Can someone remind me, what is the x value for the cosine, for the 30-degree coordinate? Yep.
Square root of 3 over 2.
3 over 2. What's the x value for the 45-degree coordinate? 2 over 2. What's the y value for the 30-degree coordinate? Yep. And what's the y value for the 45? Square root 2 over 2. Now, you might notice that when you work with the 15s and you're doing sine or cosine, a lot of times it ends up with a root 6, a root 2, and a 4. Sometimes it's plus root 6 over root 2, sometimes it's minus root 6, but it's always a root 6, a root 2, and a 4. So this is root 6 minus the square root of 2, and the common denominator this time, 4. And that's it. That's how you find the cosine of 75. Any question on that? All right, let's pick one of those other angles that's a multiple of 15. Let's try like 105. Let's just see if we can figure out how do you break up 105. And let's see if we can do it both ways. Let's see if we can write it as a sum. And see if we can write it as a difference. Because technically, you can do every single problem that I could give you as either a sum or a difference. Do it either way. if you can figure out the numbers. Okay, 105. Anybody think of two numbers that add to give me 105? And they have to be multiples of 45 and 30. Yep.
60, 45.
Yep. 60 and 45. So that's treating this problem as a sum. But you can also do it as a difference. Okay, I had to think about it for a second, but I think I got it. Anyone? Yeah, you think you got it?
135 minus 30.
Yep. You could think of it as 135 minus 30. No matter which way you do it, you're going to get the same answer. Now, we didn't talk about the coordinate for 60. We did 30. 30 degrees was root 3 over 2. 1/2. Does anybody remember what the coordinate is for 60?
It's flipped.
Yeah, you flip it. So it's 1/2 root 3 over 2. Okay, so that takes care of the coordinate for 60. We already had the coordinate for 45. We already did the coordinate for 30. How about 135? We didn't talk about the coordinate for that one today. But if you think about 135, it's just over here. It's like a, yeah?
So I was thinking that, so 30 was flipped, but it was like, if the 45 didn't just get double like the 30 did, so maybe it's like the same as 45? Would it be the same as 45? Because the 30...
Similar to 45, but there is one thing that's different.
The x value is negative.
The x value is negative.
Oh, they're negative.
It's in the next quadrant.
Right, it's in the other quadrant. So 135 is negative root 2 over 2, positive root 2 over 2. Right. If you did a 215, it would be negative, negative. 315, positive, negative. So I'm not going to go through every coordinate, but we've done them before. Okay, honestly, I think this is the hardest part right here. Just figuring out how do you take your number and break it up into 30s and 45s. But some people seem to figure that out pretty quick. Okay, so any question on the cosine, sum, or difference? Okay, let's look at the, we just did that one. Sine sum formula. I think one thing that gets tricky about these formulas, they all kind of look the same. It's just little things that are different. Okay. First thing I notice that's different is this is a plus sign here. This is also a plus sign here. When we did the cosine ones, it was switched. If this was a plus, this was a minus. Okay. With sine, it doesn't work that way. And the other thing that's different is instead of grouping your trig functions, cosine, cosine on the left, sine, sine on the right, they're mixed. So you have one of each. That's the sine sum formula. So now we could do something like sine of 15 or sine 75. Yep.
Cosine times sine is the same no matter how you flip it, right? So there's no reason why you did sine, cosine, cosine, sine.
Right. The only reason I did it sine, cosine, cosine, sine is so I could do 1, 2, 1, 2. If I write it sine, cosine, sine, cosine, then I have to think of it as 1, 2, 2, 1.
All right, that makes sense.
I just always like to think 1, 2, 1, 2. But yeah, it would be the same thing. Okay, so that's the sine sum. What do you think is going to change for the sign of a difference? Only one thing that will change. Yep.
It should be a minus sign, Right.
Yeah, this is going to be a minus. And that's going to be a minus instead of a plus. Yep. But it's the same format. You have a sine and a cosine and a sine. Your angles are still first, second, just a minus instead of a plus. Okay, does everybody have sign, sum, and difference? All right, let's try. I think I got an example. No? All right, I'll make one up. Let's do the sign of. Let's do one that is in another quadrant. Let's do the 105. Okay, because we started to do it with cosine. We never really finished it. Let's do the 105. And let's do this one over here. That's a multiple of 15, so there should be a way we can figure that out. 165. Okay, I'd like to do one as a sum and one as a difference, even though you can do both of them either way. I'd like to practice one sum, one difference. So let's figure out the 165 first. Because we already figured out 105 both ways, as a sum and a difference. So let's figure out 165, and then we'll just copy our answer we did for 105. Okay, how can we break up 165? And if you ever get really stuck, the best thing you can do is list all the angles that you can use. Start in quadrant 1 and just go up in order. 30, 45, 60. That's everything in quadrant 1. 120, 135, 150. And in quadrant 2, you got, what's there? 210, 225, 240. I think you're probably going to be able to do it with those numbers you can see there.
So,
Yep.
why do we skip the 15s if we know how to do them?
We didn't know how to do them before because we hadn't learned the formulas I showed you today. So to do the 15s, you need the formulas that we just learned. And we never knew them.
Okay.
That's why. Okay, so does anybody see how you can get 165? And I do see a way to do it with the numbers that are up there. Yeah?
45 plus 120.
Yes, yep, you can do 45 plus 120. I was thinking 135 plus 30. But 45 plus 120, that works too. As long as you can figure out the coordinate for 45 and the coordinate for 120. Yeah.
Was there a reason that 90 wasn't put up there?
Yeah, because we usually stick with the 30s and 45s. That's how it works.
Oh.
90 is a multiple of 30 and 45, yes. But 90 won't really help you to break up 105.
Yeah.
Because if you break this up with a 90, you say, oh, it's 90 plus 15. The problem is 15 is not a multiple of 30. So when you break it up, you always want to break it up into 30s and 45s. And using a 90, a 180, or a 270 is going to mess you up. Yeah. Okay, and then what did we get for 105? But as a difference. Anybody remember what we had for that?
It was 135 minus 30.
Okay, let's do it that way. Okay, so let's figure both of those out. Okay, first step. Can somebody give me just the kind of general pattern for a sign of a difference? You don't have to fill anything in, just like cosine, cosine, or whatever it is.
Sine times cosine plus cosine times
Sine times cosine. And then what is it?
plus cosine times sine.
You're doing this top one?
Yeah. Okay.
Minus. So top one should be a minus. Sine times cosine minus cosine times sine. Okay, and what are we filling in for the first angle? Yep, 135. And you're going to fill that in over here. And can someone else tell me my second angle? Yep, 30. 30. 30. Okay, so now 135. What part of the coordinate do I need for the sign? The x or the y? Yep, I need the y. So we can write it out if we need to, or if you can kind of think it through in your head. What's the y value for the coordinate for 135? Yes, it's the root 2 over 2, and it's positive because you're in quadrant 2. How about the cosine of 30? Let's see, so that's the x value of the long side, which is root 3 over 2. Yep. Minus. All right, what's the x value for the coordinate for 135? Yes. So that's a negative root 2 over 2, and there's a negative in front of that. So we'll see what happens. And then what about the sine of 30? Yep, that's going to be the y value, which is the 1/2. Now let's take care of this right away. You're subtracting a negative. So what happens when you subtract a negative? Yeah, it's going to turn into addition. So I'm just going to make that a plus sign. Okay. Anyone think they can tell me what you get for the final answer? And it's going to look similar to some of the answers we had before.
Root 6 plus root 2 over 4.
Yep, root 6 plus root 2 over 4. Perfect. Okay. And the bottom one, we're going to use the same kind of template. But what's going to go between the two parts this time? This is going to be addition. With sine, you always keep this the same. Okay. And your two angles are 45 and 120. Okay, I haven't been checking these on the calculator, but you can check it. If you type sine 165 on the calculator, and then you type in like the answer we get, the decimals will match. 120. Okay. The y value for the coordinate of 45 degrees.
Root 2 over 2.
Root 2 over 2. Now the x value for the coordinate of 120. 120 is right here. It's the 30, 60, 90 mirrored into quadrant 2. So what's the short side And remember that it's going left. Well, what's going to be the coordinate for 120 degrees?
Is that -1, -2?
No, that wouldn't be on the unit circle.
The x is -1 over 2.
Yep, -1/2. And what about the y?
Positive √3 over 2.
Yes.
Oh, I'd split them.
Yeah. Okay, so -1/2. And then √3/2 is the long side. Okay, so as Brady just said, -1/2. Okay, what's the x value for the 45-degree coordinate? √2/2. And what's the y value for the 120-degree coordinate?
Positive √3 over 2.
Yeah, positive √3/2. Oops, there you go. That. So we'll put all that together and have our final answer. Okay, what do you get when you multiply the square root of 2 times -1? -√2. Plus, how about when you multiply square root 2 times square root 3? √6. And Nick, what's my denominator going to be?
2.
Yeah, it's going to be 2 times 2, which is 4. All right. So any question on that one? So might be handy on your reference sheet if you want to put down the coordinates for like 30, 60, 45, at least those 3. Then you can figure out the other ones if you need to, or you could write them all if you have enough space.
So it's just cosine of 15?
Is that what cosine 15 came out to?
Yes.
If it is, then yes, you will see some answers that do start to repeat.
So are they all just mirrors of each other?
Yeah, exactly. Because if you think about the 15-degree, go back to the picture. Okay. The 15-degree and the 165-degree are the same triangle, except mirror imaged into quadrant 2. So yes, you keep seeing these √6s, √2s, and 4s in all of them. Yep. Every green dot on that diagram will have a √6, a √2, and a 4 in the answer. Positives and negatives, that's the only thing that changes. Yep. All right. So I told you there is a sum and difference formula for tangent. We're not going to do the tangent one. Okay, so I'm gonna skip over that one. Okay, and this will be the last one, the last formula we do. So having a 2 inside the parentheses in front of the x and having a 2 in front are not the same thing. Okay, they're not the same thing. If you're not sure why, just graph it, and you can see when I hit graph, they don't look the same. That's the one on the left. And then the one on the right, that's a vertical stretch by 2. So it's going to make it twice as tall. That's totally different. Okay, but does everyone see how they're not the same? Yeah. So this 2, though, is still a problem. When we're dealing with sines and cosines, you don't want anything inside here. Okay, I showed you how to get rid of a plus, and I showed you how to get rid of a minus. How do you get rid of a 2? Oh, that's what I'm going to show you right now. To get rid of a 2 inside parentheses, you can use that formula. 2 sine cosine. I can very easily prove that to you. I did, but I could. But we're not. Yeah.
Only a 2?
Yes, only a 2. If you got like a 3 there, yeah, that's different. So we only really look at what happens when there's a 2, because this is called a double angle identity. Yep. But if you had a 3, you could kind of think of 3 as a 2 if you did it like this. You could think of it as 2 theta plus theta, and now you have the sign of a sum, which we also have a formula for that. So you can still work with it if it's not a 2. It just involves more steps we're not going to get into. All right, so that's the formula if you have a 2 in front of sine. Here's the formula if you have a 2 in front of cosine. And this one, there's actually different ways to write it. Does anyone remember a Pythagorean identity we had that kind of looks like this? It's not this, but it has these things in it. Something with a sine squared and a cosine squared. Yeah?
Sine squared minus cosine squared equals 1.
It's something equals 1. Does anyone remember? Yeah?
1 minus cosine squared equals sine squared, or reversed.
Yeah, or you could write it this way too, but what you said is correct. Sine squared plus cosine squared equals 1. Now, can you tell me what you just said?
1 minus cosine squared equals sine squared.
That's just rearranging this one. All he did was bring cosine squared on the other side. Can anyone give me one more way you could rearrange that instead of 1 minus cosine squared equals sine squared?
1 minus sine squared equals cosine squared.
1 minus sine squared equals cosine squared. Yeah, it's all just different ways of rearranging a Pythagorean identity. I think we had, I want to say it was last week. So let's take this one. That last one tells me that cosine squared equals what?
1 minus sine squared.
Yes. It tells me that cosine squared is 1 minus sine squared. Well, if you were to plug that in, what's 1 minus sine squared minus sine squared?
1
Minus negative 2 sine squared.
Right. That's 1 minus 2 sine squared. So when I said there's 3 different ways to write this identity, all 3 ways are based off the Pythagorean theorem, Pythagorean identity that we learned last week. So I call this the first way, second way, and third way. So these formulas get rid of a 2 inside the parentheses. That's all they do. They get rid of a 2. In general, higher the number is inside the parentheses, the harder it is to get rid of. If this number was like a 12 or 13, that's going to be pretty hard to get rid of. It's going to be pretty long. It's going to be a lot of steps. But 2 is kind of what we work with. And the tangent, there is a tangent one, but we're not doing the tangent. Okay, just the sine and cosine. All right, so let's try this one. And then I think this will finish up everything that I really wanted to do in 7.5, which I think is going to give us 2 days to do 7.6. 7.6 is a harder section. So 2 days would probably be good to spend on it. So what they're asking you for here is to rewrite what you have without any 2's in front of the x. Just 1's in front of the x's. Is there any part of what they gave us that already has just a 1 in front of the x and we can leave it alone? Yeah, the 2 cosine x is fine. What can we change this to? And it will get rid of the 2 in front of the x. Yeah?
2 sine x times cosine x.
Exactly. 2 sine x cosine x. Now, all they said to do here was rewrite it so that you only had 1's in front of the x's. We've done that. So technically that is correct. But if they asked us to write our answer factored, that means to take out what they both have in common. Does anybody see what this and this both have in common?
Cosine.
They do have a cosine x, they have something else in common. 2. So if they ask you to factor your final answer, it means take out the GCF. If you factor out 2 cosine x from the first term, what do you have left? Just a 1. When you factor the entire thing out, all you're left with is a 1. How about if you factor 2 cosine x out of the second term? Sine x. That is also correct. That's the factored version of the answer. Okay, any questions on that?
When would the first answer be acceptable?
If the directions were exactly what it says here, it does not say to factor, that answer is fine. Right? If it says factor, which we're going to do in 7-6, then you have to do the second one. That's why I did this, to get ready for 7-6. Okay, so let me put up homework. I might adjust that a little bit. I'm gonna already start in a second, but let me do this. It's the same number of questions. I'm just changing them all. Actually, 17. Page is that? 417. Alright, so these questions and a hint on 37. We talked about that before. What did I just write down?
Arc sine.
Arc sine. Yep. You're going to use inverse sine on both sides. It's solving an equation, and that's how you solve it. So we'll talk more about that tomorrow, but we talked about it a couple weeks ago, but I'm not sure people would remember it. So use inverse sine on both sides. So that's the homework for tonight. Yeah.